Hey kids, we are going to do a little review of chapters 3 and 4, which have to do with linear functions, graphing lines. So let's just take a look at a few of the classic problems in these chapters here, just to dust off the old gears. Number 1 says, find the average rate of change for this function f of x equals 3x squared minus 5x plus 4 over the interval from -2 to 3 for x values from -2 to 3. And you might be saying, hey, this is not a line, and you're right, it's not, it's a parabola. But the phrase average rate of change is just another way of describing slope. That's what slope is, right? It measures the rate of change of a line. And so the average rate of change means to just do the slope on this curve between this point and this point. So average rate of change, or AROC as I abbreviate it, is slope. And maybe it's been a while, but the formula for slope is change in y over change in x, or rise over run, or y2 minus y1 over x2 minus x1, right? That's the rise, that's the run. But you need 2 points, and they've given you the 2 x values. So they're saying over this interval, so that means those are the 2 x values you use. Don't use any of the ones in between. But we need the y values. So you've got to get those y values by using the function. So the y value at -2, you're just going to plug -2 into this. So 3 times -2 squared minus 5 times -2 plus 4. If you want to use your calculator and cheat yourself, fine, go ahead, be weak. But -2 squared is +4. 4 times 3 is 12, right? Your order of operations, exponents, then multiplication. -2 times -5 is +10, and plus 4. And that gives you 22 plus 4, which is 26. So 1 point that we're dealing with is -2, 26. To get the other point, we need to plug in 3, the other end point of the interval. So I'm going back to this function, and everywhere I see x, I'm going to plug in +3, and then I'm going to use my order of operations, and just be careful here. 3 squared is 9, 9 times 3 is 27, minus 5 times 3 is minus 15, plus 4, 27 minus 15 is 12, 12 plus 4 is 16. Okay, so our other point was 3, 16. And now we're just going to do the slope using those 2 points. Okay, so remember, it doesn't really matter the order you go in with your y's, but you just have to be consistent with the order in which you do the top and bottom. So if I go like this, if I say 16 minus 26 on top, I started with this point, then I need to start with this x value. And in the bottom would be 3 minus -2. And that will reduce to 16 minus 26 is -10 over 3 minus -2, which is +5. And -10 divided by +5 is -2. There's the average rate of change, right? I mean, that stuff is all over the news these days when you're talking about the rate of change of the flattening the curve and the daily rates of change. It went up, and it went up by not as much each day. That's basically what you're doing. It's just, hey, how much did it change by divided by how much time elapsed. So rates of change are everywhere. Graphing this line. Number 2, something you guys were very good at back in the day, but maybe it's been a while. So a few ways to go about this. I think the way that most people felt good about was putting it in slope-intercept form. And slope-intercept form was y equals mx plus b form. So isolating that y, getting that y by itself. And so I'm going to move the x's to the other side, subtract 6x, subtract 6x. Then I'm left with -4y equals -6x plus 20, right? And now I'm going to divide by -4. I'm going to isolate that y. And then dividing the whole side by -4 really means dividing each one of these by -4. So I'm going to go right into that. And I'm left with positive y equals negative divided by negative is positive. 6/4 reduces to 3/2. 3x over 2, or 3 halves x. Positive 20 divided by negative 4 is negative 5. There is your equation in slope-intercept form, and that's your slope. That's your b, which is your y-intercept. That's why it's called slope-intercept form. So we're going to start by graphing this. We start with the y-intercept. That's the one point we have right now. So I go to negative 5 on this graph, on the y-axis, and I put a dot. And then the slope tells you how to go from there. That means we're going to go up 3 for every 2 we go to the right. Right? That's your rise over run. So from that point you started at, you go up 3, and then you go to the right 2. Or you could go down 3 into the left 2. But then I go up 3 to the right 2, and I put a new dot if you want to do it a few times. 1, 2, 3 to the right 2. You know, it should still be in the same line. You know, there we go. So you draw that line, and you're good to go. There's your line. Beautiful, right? Bringing back good memories, right? So how about going backwards? Here's a graph of a line. Can you write the equation of it in slope-intercept form? Well, what's the slope? What's the y-intercept? You got the graph in front of you. The y-intercept is right here where it hits the y-axis. 1, 2, 3, 4. The slope is definitely negative because it's going down. But remember, to really get it accurately, you want to find another point that it clearly passes through. So like a good point, we always said, and that would be a good point, or if you kept going, that would be a good point. And how do I go from here to there? You know, you could use the coordinates and do the slope formula, but even faster was to just say, hey, I go down 1 and to the right 3. So my rise over run is negative 1 over positive 3, or negative 1/3. And if you have those two things, the only thing you have to write is the actual equation. Y equals negative 1/3 x plus 4. The y-intercept's positive 4. Done, right? Okay, moving right along here. Hopefully this is all coming back to you. And here we go. Gotta love graphing lines. They're so much better than graphing tigers, right? Terrible. Oof. So write the equation of a line in slope-intercept form that passes through these 2 points, 8, 5, and 2, negative 7. So the two things, again, you need for slope-intercept are M and B. And I don't have either right now, so if you have 2 points, probably the easiest thing to do is let's get the slope right off the bat. You know, again, doing that slope formula, y2 minus y1. So negative 7 minus 5, or if you could do 5 minus negative 7. But if I start with negative 7, then I got to start with this as my x value, 2 minus 8. And then simplify. Negative 7 minus 5 is negative 12. 2 minus 8 is negative 6. Negative divided by negative is positive. 12 divided by 6 is 2. There's your m. So you got your slope right now. Okay. So if you've got the m is 2, you're almost there, but you got to get the b. And there were a couple ways to do this. Here was one. Here was the way that probably most people liked at the time, was to then say, okay, if the equation is y equals mx plus b, now I know that m is 2. So now I know my equation is going to be y equals 2x plus some value of b. And I am just going to plug in one of the points in for x and y, and that's going to help me solve for b. It shouldn't matter which point you use because they're both on the same line. So, I don't know, I'll go with 8, 5. So if I plug in 8, 5, remember, a point is really just saying when you plug 8 in for x, y should be 5. So I'm going to plug 5 in for y, plug 8 in for x, and solve for the b value that makes this true. 2 times 8 is 16. And subtract 16 from each side, and you'll have your b. b is negative 11. And if you know m and you know b, you are one step away from finishing the problem. All you've got to do is actually write the final answer, which is y equals m, which is 2. So 2x, and in place of b, you know it's minus 11. There is your final answer. Beautiful. Okay, and so last problem here. We're going to write the equation of a line. This time we're going to do it in point-slope form. Point-slope form definitely was not as common as slope-intercept form for you guys. So here's what point-slope form looks like. It was if you had a point, just any random point on the line. It didn't have to be the y-intercept. And the slope. Then you could do this. It was y minus the y-coordinate of the point is equal to the slope times x minus the x-coordinate. Okay, so again, if they've given me 2 points here, I'm going to start by finding the slope. That is the one thing I definitely need. So let's get that slope. y2 minus y1, 3 minus negative 9 over negative 12 minus 6. Watch those double negatives. 3 minus negative 9 becomes 3 plus 9, which is 12. Negative 12 minus 6 is negative 18. 12 divided by negative 18 is negative 2/3. There we go, simplest form. Okay, now if you've got the slope, you've got half of the problem. You just need a point to use with it. And you actually have 2 options, so it does not matter which one you use. There's 2 acceptable answers here. So if I use the point 6, negative 9 with this slope, here's what your final answer should look like. Y minus the y-coordinate of the point, so y minus negative 9, so that becomes y plus 9, equals the slope, that has to be negative 2/3, times x minus the x-coordinate of the point you're using. Done. If you had used the other point, here's what it would look like. So if I use this point along with the slope, it would be y minus that y-coordinate of 3 equals the slope of negative 2/3 times x minus this x-coordinate, and minus negative 12 becomes plus 12. Okay, and now it says change your answer to slope-intercept form. So you could actually go back and approach it this way. I just need to get b by plugging in a point. But if you remember, some people actually like this method to get the slope-intercept form because you could just take one of your 2 answers here. So if you did the first one, and remember, this is an equation for the same line. All you need to do is change it to y equals mx plus b form. So I could distribute this to clear the parentheses. And I'll have negative y plus 9 equals negative 2/3 x. Negative 2/3 times negative 6 is positive 2/3 of 6 is 4, right? You can do 2 times 6 is 12. 12 divided by 3 is 4. Or 6 divided by 3 first is 2. 2 times 2 is 4. And then subtract 9 to get y isolated. So y is negative 2/3 x. 4 minus 9 is negative 5. There's your answer. And if I did it with this, you can see I would get the same exact answer. I'd get negative 2/3 x. Negative 2/3 times positive 12 is negative 8. And after I added 3 to negative 8, I would get negative 5. So, okay, same answer either way. Kind of a cool way to get there. But, you know, hopefully this brought back a lot of good memories from the first half of the year. And if you got any questions, just let me know.